We've just finished a discussion about diet selection and basic behavior in integrated range management here at the University of Idaho. I want to go into a discussion on habitat selection among animals. In order to get there, we have to first refocus again on habitat requirements. What is it that animals are needing out on the range to determine what they're going to select and how they're going to move through that landscape. So we'll talk about some habitat selection and habitat requirement features of animals today. Okay, recall that habitat in its simplest form is just the home of an animal. It includes all the biotic factors such as peers and insects and microbes, all biotic factors that are in the environment. It also includes several abiotic features such as climate, topography, and soil, or what's called edaphic features. Basically anything that's around the animal that influences their livelihood would be part of their habitat. We talked earlier in this class about the four basic components of habitat. When we measure habitat attributes, we measure things such as water, food, cover, and space. So those are the four basic components of habitat. That's what we measure when we're assessing habitat. Let's first talk about water. Okay, water requirements definitely vary with animal depending on the species, but also depending on the weather and climate that the animal is experiencing. Let's think first about species. I've got listed here goats, sheep, donkeys, horses, cattle. And if you look at sheep, they're at about up to a gallon or a gallon and a half every 2 days. They can drink once a day, but they also could drink every 2 days. Whereas bison and cattle generally need to eat 1 or 2 times per day. So they generally eat on a daily basis. Often, like say, once or twice per day. The sheep, if you just look at this description, you can see that sheep drink less than cows on a per body weight basis because sheep are about 1/5 the size of a cow, so they should be eating 5 to 7.5 gallons, whereas cows generally drink 8 to 10 gallons per day. So sheep and goats generally drink less water per unit body mass than horses or cattle or bison. This is also just affected about how big each of those animals are, but there are species differences. One of the things that influences how much water animals drink is how much moisture is in the forage. Immature forage has a lot of water. It's not at all uncommon for grass. Before it starts to produce that stalk and starts to telescope up with that main culm of the plant, that immature grass can be 75% water. So think about it. If an animal eats 20 or 12 kilograms, or that's 26 pounds of young forage, it will consume 9 liters of water, or 2.5 gallons of just water, in the process of eating that much forage. There have been some studies that show that when steers or stocker cattle are out on winter wheat, as they do in Oklahoma and Texas, they graze winter wheat in the spring and throughout the winter. Well, that grass, at that point, that wheat is so young and so full of water that it's really not even necessary to supplement water for animals. There's so much moisture in the grass that the animals may not need the moisture at all. This is also something we'll talk about when we get into a discussion about riparian habitat and how animals seem to select riparian areas. They often do that later in the summer because there's moisture in the stream in the riparian area. There's also green grass there that has moisture, and at that same time the grass up on the hillsides has very little moisture in it as it starts to mature and go dormant. So water in the forage is a pretty important feature that influences selection and habitat. Water demand also changes throughout the year and depending on the species. Weather, of course, has a huge influence. Hot weather really increases the demand. Just think about how much water you can drink on a really hot summer day. You certainly couldn't do that on these cool days of winter. You just don't have that demand for that much water. Well, animals are the same. Hot summer days, they drink a lot of water. They need a lot of water. The physiological state of an animal also affects how much moisture they need. We talked about the energy demands of lactation earlier in the class. There's also huge demand for water during lactation. So it might be another reason to try to have animals becoming fresh and lactating when there's plenty of moisture in the environment. And then, as I just mentioned, because of these differences in when moisture is available, and because when it's hot later in the summer and animals have high demand, we tend to have a lot of use of riparian areas. For all of those reasons, animals have high demand, the grass on the uplands has low water, there's water available in the riparian areas. Okay, so now let's think just a little bit about food as a habitat element. Just remember that food is that source of energy, nutrients, and minerals for the animal. So at the minimum, food is a really important part of habitat. We often separate it, as I do, I separate food from habitat. We'll talk about habitat selection and food being a really important part of where animals select habitat, just because it's the basis of energy, nutrients, and minerals for their survival. We talked briefly about how much food animals eat. When we're talking about nutrition, it's time to just kind of bring that up again. Concentrate selectors like birds, bears, mice, anything out on the range that is not fermenting cellulose is having to really select the highest quality foods. Birds, bears, those kinds of animals eat about 1/4% of their body weight per day in forage or in foods out on the range. You might even think about yourself, take how much you weigh, see how you generally eat about 1/4% of your body weight. Sure, it goes up and down from day to day, depends on the food, but generally we think of animals eating about 1/4% of their body weight if they're concentrate selectors. The number we've used in class for ruminants is 2.5% of their body weight per day in dry matter. Hindgut fermenters like rabbits and horses eat about 3% of their body weight per day because they're designed a little bit differently. Their digestive system allows them to pass through fiber much more easily. Another thing to think about foods is it's pretty hard to just try to make a list of everything an animal eats and sort of make sense of it. So one of the things that habitat biologists do is they try to put foods in categories that make some sort of ecological sense. And here's a set of categories that make a lot of ecological sense. You could lump all foods that an animal prefers, that they eat them more that these plants are more common in their diet than they are in the food available. In other words, they are eating more than is available in the environment. So that would be a preferred food. Staples are foods that are eaten regularly to meet basic nutrient demands of the animal. They are available. They constitute the bulk of the diet, and so they are considered a staple. Emergency foods are ones that are rarely eaten, but they might be eaten in an emergency situation, such as, we talked about this with juniper trees. They're green in the winter, so we'll often see animals eating green foods, and that might be juniper. That would be considered an emergency food. It's not very high quality, but it might fulfill the short-term nutrient demands. And then the final group is fill. These are things that may not have very much nutrient value, but the animal may eat them just to try to fill up. So kind of dry, stemmy grass would be an example of fill that a ruminant might eat. When you think about managing food resources, then it's kind of interesting because you can actually evaluate a landscape on food requirements. If you know what vegetation is present and you know what the diet preferences and requirements of the animal are, you could map the spatial arrangement of foods. So here's an example. This is in the whole state of Utah, where they mapped areas that would be high bighorn sheep habitat based on food requirements. So it can be done. Next element of habitat that we'll talk about is cover. Remember, cover is important for two different reasons. One is thermal cover, shade in the summer, shelter from the cold in the winter. Both of those attributes help make an animal comfortable based on the abiotic aspects of their environment. So here is 3 figures from a publication out of Canada where it describes the thermal features of cover. Cover is also important as habitat to protect from predators. Of course, animals are born with some habitat elements. They mix into the habitat, like this deer here, that's the fawn that has the spots, that helps them be concealed in habitat. And then the animals can also learn quite quickly which vegetation gives them visual obstruction or makes them hide from predators. There's been some really good research on how animals know what is good cover, whether it's that they can't see predators or how do they know that predators can't see them. So regardless of exactly what the mechanism is, we do know that animals can find cover and hide quite well. So hiding cover that was just described for deer would be where they would hide from predators. Is another set of herbivores where protection from predators involves the lack of visual obstruction. So two good examples of that are pronghorn and prairie dogs. They both they don't like being in a bunch of cover that conceals them. They want to be able to see their predators. So prairie dogs, for example, they gnaw down all the vegetation right outside of their burrow, not because they're eating it necessarily, but just because they want to keep it so they can see predators that are approaching. The final one is space. We don't usually think space is limiting very often. I'm going to give an example of nesting, because there may be limited space for the highest quality nests in an environment. So space, we might think of on just a few attributes. Of course, there's enough space for animals out in the environment, but there might not be enough space for breeding and nesting. Animals have specific home ranges, so that might be a space requirement. Some animals defend territories. That would be a space requirement. Some animals are just intolerant of other animals in their space. They've got some personal or social intolerance for animals that are in any closer than they want them to be. And then the other aspect of space is that the less space is available, you might have some issues with disease transmission. So those are all aspects of a habitat that are influenced by the amount of space available. This term habitat selection, I've been throwing it out fairly loosely, but what I mean by habitat selection, it's just it's the act of selecting a very specific habitat among all the habitats that are available. Potential range is the area that contains all the elements necessary for growth and reproduction. So for the potential range of an animal is anywhere in its accessible area, like in North America, which would be in which the animal would be able to survive and reproduce. That's potential range. That is set by limiting factors. Any basic requirement that limits the size, growth, and quality of animal production, of an animal population, is called a limiting factor. That could be water, food, climate, topography, space. Any of those aspects could affect the selection of habitat, and certainly whether habitat was potential or not. What's interesting about this is that whichever is the most limiting factor, that's what sets the bar for everything else. So I've got this barrel. That's an often analogy that's given for a limiting factor. Is when you fill water into the barrel, you start putting resources into the barrel for habitat. In this case, the slat for food is the lowest, and when you hit that low bar, it doesn't matter if there's enough cover or enough water or enough space. The amount of food in the environment is what's limiting the growth of animals. So there are limiting factors that set the bottom bar for all the other attributes in the habitat. So how do we deal with limiting factors? What do humans do? One of the things that we do is we remove limiting factors, such as in this graph where they're feeding elk in the winter. Quite a few places where we feed wildlife in the winter because the limiting factor for them is lack of forage in the winter. We might add limiting factors like roads or fences or lack of forage. So we humans might actually lower the access that animals have to resources, and that would be a way that we add limiting factors. Another important concept is home range. It's the area in which an animal conducts its normal, annual, or daily activity. So here's just a map of the home range of a coyote in this case. You might have a sort of a core area, and then you might have, this coyote has an area that it sort of transits, and then finally you can describe a home range, which is the area that this animal spends the majority of its yearly activities in. Oh, sure, it goes out once in a while, but it will come in and out. And in this case, they spend 80% of their time in that core area, and not very much outside. Only about 7% of the area outside of that is not core habitat in their habitat. So if you kind of look at these, it describes the different aspects of core habitat for this animal. Home range is an area where they conduct their annual activity, and it can be shared with other individuals of their same species or other species. An interesting thing is it's directly related to body weight. Larger animals have larger home ranges, perhaps not surprising because they have larger set of requirements. It also is dependent on the type of animal. Carnivores have very large home ranges compared to omnivores, compared to herbivores. So if you take mountain lions, they have very large ranges versus a bear that's an omnivore would have a smaller home range versus an herbivore which could potentially have an even smaller home range. So there's models that have been developed on what is a predicted home range based on an animal's foraging habits. It does vary by diet habitats. Whether an animal is a generalist or a specialist will determine how big their home range has to be. And then finally, don't forget that human encroachment can have a really big effect on the home range of an animal. Territories are something a little bit different than home range. That's an area that an animal will defend. So within any one home range there might be an area that is an animal's territory. Some animals, like wolf packs in this example, the whole area that they use would be their territory. They would defend that area, and they spend quite a bit of time patrolling and putting out scent markers that is their area. There's not a great deal of overlap among habitats of wolves because they do have these areas that they will defend that are their territory. In this case, they are exclusive to a pack. Other territories might be exclusive to an individual, such as a breeding pair might maintain a habitat. Home ranges and territories, why does it matter? Why would animals spend energy and why would we be able to measure that they spend most of their time in one home range or territory? Well, there are some good reasons. One, it allows animals to be familiar with the foods and the threats in their home range, so they are able to really capitalize on the resources, such as the foods, developing the foraging skills, developing knowledge of that food, or avoiding the risks, such as understanding where cover is and being able to avoid the risk of predation. So territories and home range have a lot of value to animals just because they're familiar with the resources and the threats. Are there any disadvantages to this? Well, actually, indeed there are, because you can't be familiar with everything in the world. An animal cannot be familiar with all potential habitat. So once they settle in and they select one home range, it's possible that that their home range is less valuable than something that might just be over the hill or just right outside of their home range. So the disadvantage is that an animal might settle into a home range that is not really all that beneficial, that there might be something just over the hill or just outside of their current home range that's of value. Here's some interesting concepts about how animals interact with their habitat. One is this term called philopatry. It's a love for a particular place. It's a love for your home, a love for a particular place. It's usually referring to one's homeland or the place where an animal was reared. And we know that all animals tend to prefer the area that they sort of grew up in and were reared in, but some animals have very, very strong philopatry. Salmon are one of the best examples. Salmon have such strong fidelity to the place that they were hatched that they will only use that. That's the only acceptable habitat for them to go back and breed and reproduce. So that's a really extreme level of a fidelity to a home place, to a homeland. We also know that predation affects habitat selection, and we must take this into account when we're thinking about habitat. So not only are those resources, food, water, cover, space important, but also the risks of predation, for example, can affect habitat. And that's not one of those four basic elements. And then, as I mentioned before, one of the problems with selecting a habitat is that no animal has perfect habitat selection because they don't have perfect habitat information. So the quality of information can vary. Some animals actually spend quite a bit of time roaming outside of their habitat to make sure that they have all the resources available in their region. Others really settle into one home range and stick with it. So it is not possible for animals to know all about their habitat. It's not possible for them to know all appropriate habitats that are available. They may not be able to assess the habitat quality, and they may especially not know about the risk of predation. But some animals do spend more time in trying to understand the habitat around them than others. So let's think about habitat use. What do we do that affects habitat use? What are some natural events that could challenge the quality of wildlife habitat, or even cow habitat for that matter? So what are some natural events that could affect the quality of livestock or wildlife habitat? Well, I can think of quite a few. Fire, landslides, drought, use by insects. The list just kind of goes on and on. Anything that affects the vegetation or the landscape could affect habitat. There are also a whole host of human activities that challenge the quality of livestock or wildlife habitat. Fences, roads, buildings, just the act of humans walking through or driving through a landscape, trails, all of those things could improve or degrade the quality of habitat. So with that, you might think a little bit more about those elements of habitat and how animals learn them and how we change them. And that will be the basis for the next set of discussions on habitat selection.